So welcome back. So before we start the designing systems like WhatsApp, Uber, or Google Docs, or any caching system, so I have one question for you. Have you ever gone through like why most of the people fails in system design interview? What are the basic reasons? It's not because they don't know the tools like Redis or Kafka. It's because they don't understand the fundamentals, and that's exactly where we are going to fix first. Okay. So what is the system design? So system design is not a drawing of the boxes. You are drawing like some request you come in like that. No, it's not about the drawing the boxes. It's about making the correct decisions under the constraints. Okay. So what we are going to solve normally in any system design, we are going to solve the problem of scale plus performance. What else? Reliability. And of course the cost. This cost may be in terms of time or money. Okay. So let's understand one very basic example. Suppose you are going to build one city. So to build any city or any town, what you need? You need roads. First thing, right? It's a basic needs. Then you require building. Then you need some storage, maybe water storage or anything, and then traffic control. Here the roads are nothing but networking, right? Buildings are just like a service. Storage is like your database, and traffic control of course is kind of load balancing, how you're going to distribute the load. Okay. So if you don't understand the basic, your city is going to be collapsed. So this is the same concept we are going to use in our system design. So just like before speaking English, you need vocabulary. So just like before system design, you need a core concepts. Okay. So this core concept might be technology egoistic, or and it's going to be used in every system, and this is expected by when you're going to design any particular system. So normally in the interviews, you are not going to be evaluated on the tools. You are evaluated on the thinking using the concepts. Okay. So there are 6 pillars has been defined in the system design. Okay. What are those? So every system design problem is built using these building blocks. So first is of course networking. Second, your API design. Then data modeling is which database we are going to take. Okay. Fourth point is caching, and of course we are going to take care of the scaling also. And last but not the least, consistency. Okay. So these are the 6 pillars that we are going to talk about this. So let me just give you a brief about these pillars. We are going to talk about in a detail in a separate lecture, but I just want to give you a brief about this. What is the important foundation in this? So let's talk about the networking. So every system is actually a network problem. Services talk over the network to other services. Network means is equal to, you can say, latency plus failures. So this is the key idea behind this. So network means, if networking is coming, it means you have to take the best decision while taking the latency on the top and the failure handling. So maybe same network, like if same data center, let me talk about, suppose same data center might be given 1 to 10 millisecond. For the cross country, if the same data center getting accessed from the different country of different region, it might take up to 100 millisecond, right? So this is the power of networking. Okay, so like you have to think, what like HTTP, we're going to talk about the HTTP versus TCP, okay, which one is we should use. And if it is a very real-time updates, then we can talk about like WebSocket, okay. WebSocket are server-side events, okay. If it is internal, then I can talk about the gRPC protocols, right? So just remember, don't do any over engineering in the network concept unless it is very needed, okay. Now coming to the second, that is API design. So API is how you just talk to your system, right? So default, you might be aware of this. So REST API we prefer to use, and REST API is having multiple types like GET, POST. So what common mistake people do in this layer, they spending too much time on the API, okay. So you must be aware of the API design, but you have not to focus much on this right now, okay. So remember this is the way how your system going to talk, okay. It's protocols also, you can say. Now coming to one of the important one, that is data modeling. So data modeling is the heart of the system, okay. So your system is only as good as your database or data models. Remember, this is a baseline. Your system is your system is only as good as your database or data model. So there are many challenge will come, like relational DB versus NoSQL. So there are many constraints, like which one we should prefer to use, what are the conditions we are going to talk about, right? So just the rule of thumb you can remember for now: if your data is structured plus relational, means foreign key, primary key, these kind of concepts are there, okay. Relational, then go for SQL, okay, means a relational database. If data structure is not fixed, it's a flexible, maybe today coming 10 key, but tomorrow might be 12, okay. Then if I want to scale, then go for NoSQL, okay. There are trade-offs in that, so we are going to talk about that, okay. Now coming to one more core concept, caching. So what is caching? So when system becomes slow, we don't scale first, we cache. We have to identify what are the frequent access data. Let's cache them instead of fetching every time from the database or from backend, right? So frequently access data we cache. So might be from DB, the same data when we are returning from the DB, might it is taking 50 millisecond, but if it is in cache, it's going to take like 1 millisecond. So you can see the difference, right? So that's why it's very important, okay. Now there are some challenge in that, like how we are going to do cache invalidation. We are going to talk about this in a separate details video, okay. Now coming to scaling part. So when one machine is not enough, we scale. When load is going to increase, we are going to increase the machines as well, okay. So this scaling is having two way of doing this. One is the horizontal and one is the vertical scaling and horizontal scaling, okay. So vertical means you are going to take bigger machine. If suppose previous machine was having 4 GB and 256 GB of hard disk and 4 GB RAM, so in vertical scaling you are going to make in 8 GB and maybe you are going to do 5.2 GB or 1 TB. So this kinds of configuration change is called vertical scaling. Now coming to the horizontal. So in horizontal, we are going to append more machines. If one machine was serving the request, if we are feeling that okay, it's not able to cope up with the number of requests, let's add on one more machine. Then ALB will come in picture, load balancer. Its work is to distribute the request in a very proper way to each machine, so that load can be evenly distributed. Okay. So in this, when we are going to do the scaling with the database side, then we are going to talk about the sharding. It's a very important concept, and for the interview point of view, it's a golden questions are asked from this concept. So we'll focus on this. Okay. Now we are going to talk about the cap theorem. Cap theorem is, in distributed environment, we cannot achieve everything. We cannot have everything. So like consistency, availability, okay, and P stands for network partition. Okay. So basically in these two are important. We are going to talk about this only. So you have to choose either consistent system or available system. Okay. So this is a part of cap theorem. We are going to discuss that. So let me give an example so that it can be clear. Like let's say you are having one banking application where even 1 second of delay cause some consequences. So like in banking, you want consistency. Consistency is more important than availability. But in social media availability is much higher. If any message or if any post is coming after 2 seconds of delay, it's okay. But any point of time, your system should be available. If it should not be blank, that is not acceptable. So based on the project and based on the concept or context, we decide which one we should prioritize. Okay. So most of the system uses eventual consistency. We are going to talk about that only. Okay. So when we are going to talk about the detail, we are going to talk about that topic also. So remember this, eventual consistency. Okay. So apart from that, one more thing that you have to take care. Let me give one name, like load numbers. Some people used to call it magic number also. So what is this? System design is not about the guessing, it's estimating. So for any estimation, you require some data, some input. Okay. So for example, when we're going to solve any problem, you have to ask, you have to take this input from some sources, like okay, what is the operation where suppose you are going to use Redis, for example. So Redis, you are going to ask, you must have one data, like okay, this much operation per second we are going to perform. Maybe it's 100k or 200k or 1k, it depends. So that kind of number we must have in the mind. When I come into DB, so when you're going to take DB decision, so you might have some number again. So what is the TPS? Okay, so like maybe 10k to 50k TPS is coming on the database. So that much query per second is coming on DB. So this is going to help you or give some input while choosing the database. And now coming to the server. So server, like how much connection we are expecting, okay, at any point of time or in a peak time, this kind of data we must have. So like some number like okay, 100k connections we can expect. So this kind of data is going to help to do a better design. Okay, so it's a reality check actually. So remember this thing. So before designing any system, you must think in this order. Remember how service talk, it's all about networking. How user interact, this is about the API. And how data is stored, that is about the database or data model. And how to make it fast, so caching might come in picture. And the next point we discuss how to scale, right? So in scaling, horizontal, vertical, and sharding, these three concepts we are going to talk about, and how to handle the failures. So consistency, okay, this is much needed. So these are our building blocks. So now we understand the fundamentals. Let's move one of the most powerful pattern in the design system, that is real-time update pattern. So it's a kind of syncing the data. Okay, we're going to talk about this. So let's see you in the next lecture.